So there's going to be a couple tricky applications in this video. The first one is this example number 4 from the book, where it gives that one angle of a triangle measures 4 degrees less than twice the second angle, and the third angle is 20 degrees greater than the sum of the first two. Find the measure of each angle. One thing it doesn't say is this: the three angles in any triangle always add up to 180 degrees. So to solve it now, we're going to use the facts they give you plus this fact that I'm telling you about triangles to put together some equations. And in order to do that, we first need to define the variables in those equations. So the first unknown quantity that it talks about here is the one angle. So let's say that x equals that one angle, and we're just using degrees here for the units. And the second angle, let's call that y. And z can be the third angle. And we're measuring all of these in degrees. So now let's take the sentences they're giving us here and try to convert it into an equation. So what it says is that one angle of a triangle, that's x, measures, that means it is, basically, when you measure it, it is 4 degrees less than twice the second angle. So 4 degrees less than twice the second angle. So twice the second angle would mean 2y, and then 4 degrees less than that would be 2y minus 4. So that's that first thing it's saying there. The next thing it says is the third angle is 20 degrees greater than the sum of the first two. So that means z is, well, the third angle is, the is means equals, 20 degrees greater than something. That means 20 degrees plus something, or we could do plus 20 degrees here. But the thing that it is 20 degrees greater than is the sum of the first two. So the sum of x and y means x plus y. So that gives us two equations with these two variables. We still need three equations, so that's where this handy hint comes in. They always add up to 180 degrees. So we can write that as x plus y plus z is equal to 180. Now that we have three equations with three variables, we can solve it using the methods from the section, the Gaussian Reduction method. To do that, it's nice to have all of the variables on the same sides. So I'm going to take this equation and just subtract 2y from both sides. So that will become x minus 2y equals negative 4. And this equation, I'm going to subtract x from both sides and subtract y from both sides. So that will now look like negative x minus y plus z equals 20. And with this one, it's already got them all right where we want them. So now we can use elimination, and there's actually a pretty straightforward way to eliminate stuff here. Because this has a negative x and a negative y, it actually lines up nicely with this x, this positive x and this positive y. We can actually eliminate both of these variables in one step with this orange equation plus the black equation. So that will give you 0x plus 0y plus 2z equals 200, and you can just divide both sides of that by 2 to get z equals 100. And once you have z, you can then plug that into the other equations to find x and y. Here's the orange equation with that z equals 100 plugged in, and then you can just subtract 100 from both sides of this to get an equation negative x minus y equals negative 80. And once you have that, we should be able to combine that with this original green equation here, because we have a negative x and an x that we can add up to cancel out the x's. And that's going to give you negative x plus x is 0, negative y minus 2y will give you negative 3y, and that will be equal to negative 84. So here we can just divide both sides by negative 3. That gives you y equals 28. Yeah. And then you can use that value of y and your value of z that you found to solve one of these equations for x. I'll just take this x minus 2y equals negative 4 equation here. And plugging in y equals 28 should give us x minus 56 equals negative 4. And if you add 56 to both sides, you'll end up with x equals positive 52. And that should be the answer to the question. Well, it's not exactly answering the question yet. It should be the solution to the system. But to actually answer the question, you need to look at what was actually asked. Find the measure of each angle. So the one angle was x, that is 52 degrees. And the second angle is 28 degrees, and the third is 100 degrees. Here's another example of a tricky sort of word problem with this type of thing. I'm going to do the part where you set up the equations, but I don't want to actually solve them for you. I'm going to leave that as an exercise for you to practice that. But I will show you how to set them up, but I still think you should try to set them up on your own. So please pause it here and read it and try to get started. And when you get stuck, unpause it. Okay, so let's look at how we can approach this if you're stuck. First thing to do is to make up a variable for the thing that it's asking for. So it says how many acres of each crop he should plant. So let's call that W, C, and S for wheat, corn, and soybeans. And let's see what we can say about these quantities. Well, first of all, he has a total of 1,300 acres to plant all of this stuff. So we can turn that into one equation. And that equation can just be that these all have to add up to 1,300. Now, we can also get an equation about the cost of the seeds. It tells you how much he'll have to pay for seeds per acre. So to get the cost for seeds, we can say that it's $6 for an acre of wheat. So the cost of the seeds for that acre are going to be 6 times W, plus the cost, $4 for an acre of corn, is going to be $4 times the number of acres of corn. and then $5 for seeds for an acre of soybeans. That will be 5s. And he has this much money to spend on seeds, so that means the total cost of the seeds needs to add up to that 6,150. So that's what this says. The total cost of the seeds adds up to $6,150. And he can count on this volume of water and so we can make an equation about that. So it's given that an acre of wheat requires 5 acre-feet of water, so that means you can multiply 5 times the number of acres of wheat to see the total volume of water. So that's going to be 5 acre-feet of water per each acre of wheat. So 5 times the number of acres of wheat gives you the amount of water for that, plus 2 times the number of acres of corn, and an acre of soybeans requires 3 acre-feet of water. So the number of acres of soybeans is S, multiply that by 3 to get the water needed for soybeans. That needs to add up to the total of 3,800 acre-feet. So that gives you your system of 3 equations. Now your job is to solve it. And this is one of the tougher kinds of problems in the section. There are some pretty hard problems in the section. So make sure you're budgeting enough time for being able to do these problems later on. And I will see you in class.